If you were ever appointed the head of your country's defense acquisition office and you were staring down a threat on your northern border with an air force full of aircraft that were old when your pilots were in high school, you wouldn't need to look very far for a solution. South Korea has already figured it out. And in 2026, the answer is flying operational combat missions over the Korean peninsula under a name that translates, rather perfectly, to Young Hawk. The KF-21 Boramae is not just a fighter jet. That needs to be said up front, because if you walk away from this thinking it's simply another aircraft that a country built to fill its hangars, you've missed the most interesting part of the story. The Boramae is proof that a country with no meaningful history of domestic fighter production, a country that was still flying F-5 Tigers and F-4 Phantom IIs in the early 2000s, could, within a single generation of engineers, develop a combat-capable, twin-engine multi-role aircraft that the world's largest militaries are now lining up to evaluate. More than that, it's a blueprint, a working model for how a medium-sized country builds a defense industry from the ground up without going broke or going mad trying. That story, the how, the why, and what comes next, is what we're here for. So let's start at the beginning. Cast your mind back to the early 2000s. South Korea's Air Force was a collection of everything the country had managed to acquire over the previous 3 decades. F-5 Tigers, F-4 Phantom IIs, Cessna A-37 Dragonflies. Legacy platforms that had seen their best days. The country was in the process of upgrading with F-16S and later F-15K Slam Eagles from the United States, which were genuinely excellent acquisitions. But every one of those purchases came with a string attached. When you buy your aircraft from a foreign country, that country decides what technologies it will and won't sell you. It can pause deliveries. It can change its export policies. It can prioritize its own production schedule over yours. South Korea understood that depending entirely on imported combat aircraft was not a long-term strategy for a country sharing a land border with one of the most unpredictable military forces on the planet. North Korea's air wing was growing. Aging, yes, but numerically substantial and getting harder to predict by the year. And while Seoul was modernizing through imports, something else was happening that made the entire situation feel more urgent. In the United States, the F-22 Raptor was entering service, a 5th-generation stealth fighter with capabilities so far beyond anything else flying that it might as well have arrived from a different decade. The Americans made clear very early that the F-22 would never be exported, not to allies, not for any price. 2 things had become painfully obvious to Seoul. First, South Korea would have to keep constantly upgrading its Air Force's capabilities to keep North Korea at bay. Second, and more importantly, it needed to develop the ability to produce competent aircraft domestically, because it lacked not just the hardware but the foundational knowledge, the systems integration experience, the aerodynamics testing infrastructure, the entire industrial pipeline. The KFX program, which would eventually result in the KF-21 Boramae, was announced in 2001 as the response to both problems at once. And in classic bureaucratic fashion, it nearly didn't happen at all. The Korea Institute for Defense Analysis reviewed the KFX concept and concluded, fairly directly, that South Korea probably couldn't pull it off. The domestic aerospace sector simply wasn't there yet. This conclusion triggered nearly a decade of institutional second-guessing. Decision-makers, unwilling to either fully commit or walk away, commissioned feasibility study after feasibility study. The final tally was 10. 10 separate analyses over 9 years to determine whether building a homegrown fighter was worth the financial and industrial risk. I imagine the engineers involved aged considerably during that process. The 10th study finally arrived at a verdict. Yes, the risk is real, the investment is enormous, and success is not guaranteed. But the strategic independence it grants and the economic ripple effect if it works make this worth doing. Greenlight the program. That verdict arrived with some powerful external persuasion behind it. In March 2010, the ROKS Cheonan was sunk in the Yellow Sea. 46 sailors died. A multinational investigation attributed it to a North Korean torpedo. 8 months later, North Korean artillery shelled Yeonpyeong Island, killing 2 soldiers and 2 civilians. The argument for strategic self-reliance in defense manufacturing had never been more visceral. The KF-21 program was officially launched in 2010 with 4 goals that would define every decision made in the following decade. Build a reliable multi-role fighter with stealth capabilities, but optimized for long-endurance patrol rather than deep penetration. Design it for efficient mass production so fleet numbers could actually scale. Engineer it from day one to accept upgrades throughout its service life. And make it exportable so the program could generate revenue and offset what was going to be an enormous development cost. 4 goals, 1 aircraft, roughly a decade to produce a flying prototype. That was the bet. Now, here is where the KF-21 story gets genuinely interesting, because the design philosophy behind the aircraft is just as important as the aircraft itself, and it is also the thing that most people overlook entirely. The team running KFX made a deliberate, somewhat counterintuitive choice early in the program. They decided not to build the world's best stealth fighter. They decided not to compete with the F-22 or the F-35 on pure stealth performance. Instead, they looked at South Korea's actual operational requirements: coastal patrol, rapid interception, sustained sorties over a defined zone, and they engineered exactly to that specification. Nothing more, nothing less. What they determined was that the Boramae needed a radar cross-section better than the Rafale, the Eurofighter Typhoon, and the F-16, but not as developed as the F-22 or the F-35. Such extreme stealth would be mostly unnecessary for the patrol mission, and it would also massively increase maintenance costs, flight hours overhead, and development risk. That discipline, knowing precisely what you need and refusing to be seduced by what sounds more impressive, runs through every aspect of this program. And it is the single biggest reason the Boramae is entering service in 2026, while comparable national programs elsewhere are still years from their first flight. More on that in a moment, because the comparison is instructive. The second philosophical pillar was equally critical. Adopt as much already developed technology as possible. Don't reinvent the wheel unless you absolutely have to. When KFX started, about 65% of the technology required to build the aircraft was already in Korean hands. After conducting wind tunnel tests on the F-35's airframe geometry, the engineering team concluded that number was closer to 87%. The remaining gaps were identified, prioritized, and addressed through a combination of licensed technology transfers, foreign partnerships, and, only where no other option existed, original domestic development. The result was an aircraft that Korea Aerospace Industries could take from blueprint to flying prototype in a decade. In the world of modern defense programs, that timeline is almost unheard of. Now let's talk about what the KF-21 actually is, because the jet deserves the attention. If you put a KF-21 next to an F-22 Raptor, the visual resemblance is striking enough to demand an explanation. Both aircraft use angled vertical stabilizers designed to scatter incoming radar waves. Both feature a blended wing body where the fuselage and wings flow into each other without a hard boundary. Both carry diverterless supersonic inlets, and that specific technology choice tells you something important about how the aircraft was engineered, so it's worth spending a moment on it. When any aircraft moves through the air at speed, a slow-moving layer of air builds up along the fuselage surface. This is the boundary layer, and it thickens the faster you go. If it gets sucked into the engine inlets, it disrupts airflow and causes pressure instability, a problem that gets significantly worse at supersonic speeds. Traditional solutions involve either a mechanical suction system to remove the boundary layer or a splitter plate physically separating the inlet from the fuselage. Both approaches add weight. The splitter plate creates its own aerodynamic disruptions on top of that. Diverterless supersonic inlets solve this differently. They sit slightly away from the fuselage, and that gap, the boundary layer diverter, allows the slow surface air to pass through without entering the engine. The inlet shape itself then generates controlled shocks that maintain stable, compressed airflow at high speeds. The F-22 uses this system. The F-35 uses this system. The Boramae uses this system, and crucially, the inlet geometry has a secondary benefit. By positioning the inlet on the shoulder of the fuselage at a carefully calculated angle, it reduces radar exposure of the engine face, which is one of the most reflective surfaces on any conventional aircraft. The Boramae's edges, inlets, wings, tail surfaces, nozzles, are all swept back at matched angles. When radar waves hit an aircraft, those surfaces bounce energy back toward the source. By setting all major reflecting surfaces at the same angle, the designers concentrate radar returns into very narrow spikes rather than a broad signature, dramatically reducing detectability across most engagement geometries. The Boramae isn't fully stealthy, only its wings, tail, and control surfaces are covered in radar-absorbent material. The main body is not. That is a Block 1 decision we'll come back to. But it achieves the goal it set out to achieve. It's stealthier than the F-16, the Rafale, and the Eurofighter, while having enough internal volume to introduce a weapons bay and full RAM coverage in future variants. Those fourth-generation platforms, for comparison, have already maxed out their internal space. There is nowhere left to grow. The Boramae was designed so that growing is exactly what it does. Power comes from two General Electric F414 turbofan engines, each producing around 13,000 pounds of thrust, the same engine family that powers the FA-18 Super Hornet, adapted for the Boramae's airframe and produced locally in South Korea under contract with Korea Aerospace. Twin engines serve two specific functions here. On long coastal patrol missions far from a runway, one engine going offline should not mean the loss of the aircraft, and at air-to-air combat configuration, the combined thrust delivers a thrust-to-weight ratio of approximately 1.15, giving the Boramae serious energy maneuverability. Maximum speed sits at Mach 1.97. Internal fuel capacity is 5,400 kilograms, giving it a combat range comfortably greater than the F-16, which was a hard requirement given the coastal patrol mission this aircraft was designed to fly. Now, the avionics package is where South Korea had to do the heaviest original lifting, and it's also where the geopolitics of weapons technology become impossible to ignore. South Korea struck a deal with Lockheed Martin, purchased 40 F-35s, and received technology transfers in exchange. The United States agreed to most of it, then blocked 4 specific systems: the active electronically scanned array radar, the infrared search and track system, the electro-optical targeting pod, and the electronic warfare suite. These 4 technologies were considered too sensitive to share with any foreign partner, regardless of how close the alliance. South Korea would have to develop them independently. Here's the thing, though. Because the vast majority of the Boramae's other components were already sourced or licensed, Korean engineers had enough time and resources to go deep on those 4 systems. The AESA radar was developed with guidance from Israel's Elta Systems and Sweden's Saab, and the result is a system capable of simultaneous air-to-air, air-to-ground, and air-to-sea detection, along with terrain-following modes that allow the aircraft to fly at very low altitudes safely. The infrared search and track module received sensor head input from Italy's Leonardo. The electro-optical pod and electronic warfare suite were developed with internal Korean expertise, supplemented by knowledge built through those partnerships. What South Korea ended up producing is a genuinely modern fighter avionics suite, not borrowed, not imported off the shelf, but built. That matters enormously for what comes next. The prototypes proved it. 6 flying Boramaes conducted over 2,200 test flights covering the full envelope. Supersonic runs, night operations, aerial refueling, high angle of attack maneuvers, live weapon releases, icing conditions, heavy rain. At the point of initial service entry, those prototypes had logged more than 1,600 of those flights without a single accident or incident that is genuinely exceptional. All aircraft, no matter how well designed, encounter problems during testing. That's the point of testing. The only modification the entire KF-21 test campaign required was a flattening of the engine nozzle geometry to eliminate a minor vibration that appeared under very specific flight conditions. One change: 1,600 flights. The engineers could barely find anything to fix. Now here is where we have to talk about Turkey, because the comparison is impossible to ignore and frankly too instructive to skip. Turkey started its own indigenous fighter program, the TAI-CON, at roughly the same time South Korea started KFX. Both countries announced their intentions around 2010. Both were attempting to establish domestic fighter production for the first time. Both faced significant technical and industrial hurdles going in. Turkey decided to build a 5th-generation stealth fighter from the outset. Full stealth, full internal weapons bay, 5th-generation avionics, the most ambitious possible version of the project right from the start. South Korea decided to build what it actually needed, adopt available technology wherever possible, and deliver a capable aircraft on a realistic timeline. The Boramae is entering service in 2026. South Korea expects to have approximately 100 of them operational by 2030. Turkey's Khan will not enter service before 2030 at the earliest. By the time the first Khan reaches operational status, South Korea will have been flying the Boramae for years, will have accumulated thousands of hours of real operational data, and will already be well into development of Block 2 and Block 3 variants that will make the current aircraft look like a warm-up act. The Khan may well turn out to be an excellent 5th-generation fighter. Nobody is saying it won't. But the Boramae will have been improving for half a decade before it crosses the finish line. Slow and steady, as it turns out, does win the race, even in aerospace. So what does the roadmap actually look like? Because the Block 1 aircraft entering service now is genuinely just the beginning. Block 1 is a 4.5 generation platform by the program's own definition. It carries weapons externally on 10 hard points, no internal weapons bay, radar-absorbent materials on the wings, tail, and control surfaces, but not the full fuselage. Both Block 1 and Block 2 aircraft carry a 20mm Vulcan autocannon with 480 rounds and can employ the Meteor Beyond Visual Range missile, the Iris-T short-range missile, the AIM-9X Sidewinder, and future domestically developed Korean air-to-air missiles. Block 2 adds the Cheonryong long-range cruise missile and a full strike package, unguided general-purpose bombs up to laser-guided bunker penetrators. It also introduces a reconnaissance role and significantly expanded attack capability. Block 3 is where the aircraft crosses into 5th-generation territory. An internal weapons bay gets integrated, dramatically reducing radar signature during weapon carriage. Full radar-absorbent material coverage extends across the entire airframe. The AESA radar gets a next-generation upgrade, and perhaps most significantly, a domestically developed Korean engine is expected to replace the KF-414s, completing the final piece of true strategic independence for Korean air power. At that point, South Korea will be designing, building, and powering its own frontline combat aircraft without a single critical dependency on a foreign supplier. Blocks 2 and 3 also introduce manned-unmanned teaming, and this is worth understanding as a concept because it's where the Boramae story gets genuinely forward-looking. The two-seat variants will be configured so that the front pilot handles flight operations and immediate threats, while the rear seat operator manages unmanned collaborative combat aircraft, drones that fly in formation and extend the Boramae's reach, sensors, and weapons options. South Korea is developing two types, a medium drone capable of air-to-air and air-to-ground strikes, and a smaller vehicle optimized for reconnaissance and electronic warfare. Together, a crewed Boramae with a drone wing becomes something that starts to look less like a conventional fighter and more like a sixth-generation air combat system. Block 3 will also deliver a carrier-based variant with approximately 20% larger wings for slow-speed stability during carrier approaches, folding wing capability, and likely short takeoff and arrested recovery compatibility. The business case for all of this on the export market rests on things that are genuinely unusual among modern fighter programs. Start with the operating cost. The Boramae's flight hour is expected to come in below $20,000, including operations and support. Compare that to the F-35 at approximately $50,000 per hour, the Eurofighter Typhoon at roughly $60,000, and the F-22 approaching $100,000. For a country that needs capable fighters but cannot sustain the operating costs of the most expensive Western platforms, that number is the difference between a procurement conversation and a signed contract. Then there is the open architecture. Most comparable fighters run on closed software systems, meaning that integrating your own weapons, your own communications hardware, your own electronic warfare packages requires renegotiating with the original manufacturer and often years of modification work. The Boramae was built to international open architecture standards from day one, which means foreign buyers can integrate their own national systems without needing Korean or American approval for every change. For countries with their own defense industries and their own weapons they want to use, this is potentially the deciding factor in any procurement decision. Poland, which already operates Korean Aerospace Industries' Fa-50 light attack aircraft, has evaluated the Boramae and is reportedly considering a purchase of around 32 aircraft. The UAE and Saudi Arabia have both exercised evaluation options and are in discussions about co-funding Block 2 and Block 3 development in exchange for delivery priority, which would make future development cheaper for South Korea, while giving both Gulf states early access to the upgraded variants. Indonesia, which contributed 20% of the original program funding back in 2010, is receiving 48 Block 1 aircraft and has already committed to at least 16 Block 2 units. The Russian Su-57, for comparison, took 10 years from its first prototype flight to the first production aircraft. The Boramae went from first prototype to active service in 5. That timeline was not achieved by luck or by throwing unlimited money at the problem. It was achieved by a disciplined program management philosophy that prioritized delivery over ambition at every decision point. Adopt what exists, develop only what you must. Build the knowledge base in parallel with the aircraft so that the engineers who finished this program are already capable of building something more advanced. That is exactly what happened. The team that built Block 1 knows how to build Block 3. The industrial base that manufactured one Boramae knows how to manufacture 100. Only about 65% of the current aircraft is produced in South Korea, and only about half of those components were actually developed domestically. That number is going to change significantly with each subsequent block. The plan from the beginning was for the Boramae to become more indigenous over time, not less, and for South Korea's defense industry to grow with the aircraft rather than simply receiving a finished product. A bit ironic when you think about it. An aircraft built partly with foreign components, specifically so that the country that built it would eventually stop needing foreign components. What the KF-21 program represents, in the end, is not the aircraft as it exists today. Block 1 is capable, it's combat ready, and it's entering service on time with an extraordinary clean test record. But the more important thing it represents is what it proves is possible. A country that was operating Cessna light attack jets in the early 2000s now has a modern twin-engine multi-role fighter in production. A country that had to import virtually every capable aircraft it flew now has the industrial infrastructure to design, build, test, and upgrade a top-tier combat platform without asking anyone else's permission. And a country that spent 9 years arguing over whether to start the program at all is now teaching the rest of the world's medium-sized militaries how to run one. In a decade, the Block 1 aircraft entering service today will look modest next to what's coming out of Korean factories. The same airframe, the same architecture, the same engineers who built the young Hawk will build something that makes it look like the prototype it was always meant to be. That, more than any specification or flight test result, is what makes the Boramae one of the most consequential defense programs of the past 20 years. The young Hawk is in the air, and it has barely begun to climb. The question South Korea asked itself in 2001, do we keep buying someone else's jets forever, or do we take the risk and try to build our own, is one that dozens of countries are asking right now. Brazil is asking it. India is asking it. Several countries in Southeast Asia are asking it. And if any of them want a model for how to do it right, they don't need to look further than the Korean Peninsula. Not because South Korea had some natural advantage that other countries don't have, but because it made the right choices at every major fork in the road. It defined what it actually needed. It refused to be seduced by the most impressive possible version of the program. It adopted available technology rather than spending a decade reinventing it. It partnered strategically without surrendering control. And it delivered on time, within budget, with a test record so clean it looks implausible until you realize that clean records don't come from luck. They come from discipline applied consistently, from the first line of code to the final flight test. The Boramae is a 4.5 generation fighter today. It will be a 5th generation fighter in a few years. It will be commanding drones and operating from carriers after that. Every one of those capabilities was planned before the first prototype ever left the ground. That is not ambition running ahead of reality. That is ambition being managed by people who understood exactly what they were doing and exactly what order to do it in. That might be the real lesson of the Boramae program, not what South Korea built, but how they decided to build it. And if the aircraft's performance so far is any indication, the decisions made in those early years of the program are going to look better and better with every year that passes. The young Hawk doesn't just fly, it learns. And for the countries watching from the sidelines, doing the math on their own air fleets, calculating whether they can afford the risk of attempting something like this, the Boramae is the clearest possible answer to that calculation. You don't need to be America. You don't need a century of aviation heritage or an unlimited defense budget. You need a clear mission, a realistic timeline, smart partnerships, and the discipline to stick to your plan, even when everyone around you is telling you to be more ambitious. South Korea had all four. The result is entering active service right now, ahead of schedule, under budget, and with a flight test record that experienced aerospace engineers are still struggling to fully explain. Not because the Boramae is magic, but because the program that built it was managed by people who refused to let it be anything other than exactly what it needed to be. That, in the end, is harder than building the most impressive fighter in the world, and it matters more